chapter 3, lesson 11, and we started this one in class already, so we're going to kind of pick up where we left off in class. So what we did was we went ahead and we looked at the thirds and the halves, and then we added those together. And so from here we have 3 over 3, which we know equals 1 whole. And here we have 3 halves, which we've talked about how it equals 1 1/2. So now all we have to do is combine these two, and then we'll have our answer. So 1 plus 1 1/2 would be 2 1/2. And then here, the next two fractions he drew are 1/6 and 1/6, so that would equal 2 6. And then here we have 3 fractions, and don't let it distract you or get you off track when we have multiple denominators, but when they're out of order. We can still add the 2 halves together. So this half plus the half here equals a whole, right? And then that just leaves us with the 1/3. So I would add the 1/3 to the back of 1 to get 1 1/3. So 1 1/3. Mackenzie was playing fraction captured and rolled a 6 and a 2. Write an addition expression to show fractions she could have captured if she used her dice rolls to form 2 6. So 2 6, well, what could make 2 6? It could be 1/6 plus 1/6 would equal 2 6. Or I know that 1/6 is the same as 2/12. I could say 1/12 plus 1/12 plus 1/6 equal 2 6. Write an addition expression to show fractions she could have captured if she used her dice to form 6 over 2. So that's the same as having 6 halves. So we could do 1/2 plus 1/2 plus 1/2 6 times to equal 6 over 2. That would have worked. Or we could have done a combination of different ones as long as the numbers equal 3 wholes, right? So I could have done half plus half. Well, that equals a whole, plus 1/3 plus 1/3 plus 1/3. Well, that equals a whole, plus 1/4 plus 1/4 plus 1/4 plus 1/4. I could have done it that way as well. So many different ways to represent each of these fractions. Now here we have, write each of the fractions below as a division expression. Then write each fraction as a whole number or a mixed number. So in class we set these up this way to help you guide it. But remember, this outside number is always the denominator, always. And then our remainder when we divide becomes our numerator. But if we don't have a numerator, because we're just looking at it here, the numerator here or the dividend here becomes our numerator. So my division expression would just be 5 divided by 4, and as a mixed or whole number, then I would actually do the division here. So 4 goes into 5 one time, then we subtract. Now my 1 becomes my numerator, and my denominator stays the same. So 5/4 is the same as 1 1/4. Okay, now here I have another division expression. So this would just be 16 divided by 8 equals what? Well, how many 8s are in 16? Well, there's 2, right? That's a math fact for us with no remainder. So it's just a whole number there. Now, how many 3s are in 14? So this is 14 divided by 3. 3 goes into 14 4 times. And then we subtract. Our remainder is 2. So 2 is the numerator, 3 is the denominator, and 4, the quotient, is the whole number. Then 12 goes into 17 one time. Oops, I forgot to set it up. 12 divided by 17. Subtract. 5 is the numerator, 12 is the denominator, and 1 is the whole number. Don't forget to do that back side.